With this video, we're going to start chapter 2, which is called Descriptive Statistics, and starting with section 2.1. We're not going to do stem plots because we won't really use them later. If you want to read about them, that's fine, but we are going to look at line graphs and bar graphs. And so first, line graphs, also known as frequency polygons. So line graphs is what it says in the book. Later on, they start using the term frequency polygon. It means the same thing. Line graphs is what it looks like. So that's a good name for it. But frequency polygons, a frequency polygon is what it represents. So it's frequencies. And polygon is a shape made out of line segments. So it really does say the same thing. It's just with this one, it's emphasizing the nature of the values are from frequencies. The x-axis in our graphs is going to indicate, x-axis indicates data values. So the values of the variable that we're looking at is along the x-axis. And the y-axis indicates, for each one of those data values, the frequency. So that's the basics of it. X and Y, XY plane is what we're going to graph it in. Let's see an example of how this works from some actual data. Like most of the things in this book, I'm not sure if this is real data or fabricated or simplified or maybe even just made up, but the statistics still applies. And if you use it with real data, you get real statistics. So in this example, that's based on 2.4 in the text, example 2.4, a survey of 40 mothers were asked how many times a teenager must be reminded to do chores. So there's kind of implicitly, they're saying that these mothers are mothers of teenagers. And we're asking each mother how many times they have to remind their teenager to do chores. I want to take this down, but that's the problem. The data I want to write there so that I can write the graph beneath it. So here's the data, and it's given in a table, number of times reminded. I think that makes it clear what that is. So how many times does the teenager need to be reminded? And there's only going to be 2 columns here. So the options there are 0, they don't need to be reminded. They need to be reminded once, twice, 3 times, 4 times, or 5 times. So each mother in this survey of 40 mothers responded with one of these 6 numbers. And the frequency tells me how many of those mothers responded that their teenager needed to be reminded 0 times, that was 2. How many mothers responded that their teenager needed 1 reminder, that was 5. 2 reminders was 8. 3 reminders was 14. 4 reminders was 7. And 5 reminders was 4. I think I wrote too big to fit my graph here or here. So copy down this data so you can look at it. That's where I'm working from. To build, the next step we're going to do is to build the frequency polygon, or the line graph. There's the data. You can pause if you need more time to copy that down. Here's the axes. So this will be my, I'm not going to call it the x-axis. I'm going to call it the number of times reminded axis, where those numbers times was either 0, 1, 2, 3, 4, or 5. As I said earlier, the x-axis is where my data values go. Now the frequencies, one of those frequencies was kind of large. One of those frequencies was 14. So I think it's easier to go up to multiples of 2 or powers of 2. So if I go up to 16 and cut it in half, that's where 8 is. And if I cut those in half, that's where 4 and 12 are. And I can cut those in half to get the 2, 6, 10, and 14. I'm not sure if you need to label all of those, but if you, we've got some odd numbers, so in between those are all the odd numbers that I'm not going to try and fit on here. But there's my scale for this frequency. The number of mothers that had to remind their teen 0 times was 2. The frequency was 2. The number of mothers that needed to remind their teen once was 5. So I'm going to plot the point 1, 5. The number of mothers that reported that their teen needed to be reminded twice was 8. 2, bring it up to 8. Reminders 3, the frequency was 14. That's the big one. It's way up about here. For the 4 reminders, the frequency was 7. So I'm going to plot 4, 7. And then for the 5 reminders, we were at 4, the frequency of 4. 4 mothers reported that they had to remind their teen 5 times. But this gives us the kind of the skeleton of the frequency polygon. It's by plotting those points from the table. You've probably done that before, but you're just thinking like X number, Y number. Here, it's explanatory variable, response variable, something like that. It's there's a little more to it, but plotting the points is the same process. You'll notice those points don't lie on a line, but if I connect them each to the next one, as I go from left to right, I get what's called a polygon. It's a shape that has straight line segment edges. It's not a closed polygon like we're used to working with, but like a square or a pentagon. But it's still, well, this is a frequency polygon. And that's the goal of this example, is to build this frequency polygon. And keep in mind though, the book might ask for line graph. That is the same thing. As far as I can tell, those two terms mean exactly the same thing. I want to do one more thing with my frequency polygon, which is to label it in a brief but meaningful way. The number of reminders is what this x-axis represents. The frequency of each of these number of reminders is what the y-axis represents in this case. So there's the finished product. Next, we're going to look at a bar graph, and I've got a different example to demonstrate bar graph. there's something related to a bar graph that we're going to study in much more detail called a histogram. We're not doing that yet, though, and there is a difference between a bar graph and a histogram. They look similar, but what makes a bar graph different is that the bars are separated. Separate bars. So there's a gap between the bars, and you'll see that in my picture. In this example, which is 2.5, it says in 2011, Facebook had over 146 million users in the United States, which is a lot. There's a little over 300 million people in the country. Almost half of them were on Facebook 9 years ago. In this problem, let's see, I can put the data here, but I'm going to need to clear this off to build the bar graph. But the data is divided into three pieces. So first is the age group. I mean, there's a lot more data on Facebook. Facebook is kind of a data collection agency. But in this example, all we're looking at is three age groups. The 13 to 25 age group, the 26 to 44 age group, and the 45 to 64 age group. In the next column, I'm going to put the number of Facebook users, but number of users that are in that age category. We could think of this as the young, middle, and older groups. I'm sure there are Facebook users above 65, and there's probably Facebook users under 13, but for this data, my number of users is 65 million. For this category, the middle, or the in-between 20s, 30s, and 40s, it's 53 million. And for the older group, it's 28 million. And I rounded these a little bit to keep them easier to write, but I think it's easier to read, and it's more informative if you just think about the number of millions rather than having 6 more digits after this to keep track of and write down. Round it to the nearest million. That's going to give us a pretty good idea. The last thing I want to put is the proportion of Facebook users. And what I mean is, imagine this is everybody. These are all the Facebook users. What proportion are in this smallest age group, or the lowest age group? Think of it as the percentage, and in this case, that's 45%. 0.45 if you want to really put the ratio or proportion down, but 45% is the same number. For the middle age group, it's 36%, and for the higher age group, it's 19% of the Facebook users. I'm not talking about the proportion of the people that in the country that are in that age group, or the proportion of the people in the country that are in that age group on Facebook, but the proportion of the Facebook users in the country that are in that age group for each one of these. And I'm actually going to make a bar graph that's based on these proportions rather than the numbers. The thing is, if I did it with the numbers, it would be exactly the same shape. It would just have different labels. I would go up to 65 million for this, up on the y-axis. For this one, I'm going to go up to 45%, but relative to the other categories, I mean, these numbers are where these proportions come from. So it should look the same. And yeah, I do want to take this down, but my three groups, I can really kind of summarize by 45, 36, and 19% for each one. Young, middle, older, if you want to label that, but that actually contains the information that I need to build this proportion bar graph for the three age groups. So if you need to, well, give yourself space because the graph is going to be big. I mean, not necessarily, but I'm trying to build it as if I were constructing it from scratch. If you already know what it looks like, you could make a small version, but it's easier to build it if you give yourself space to do so. There are three categories, and I am going to label them with their age ranges. It was a 13 to 25, 26 to 44, and 45 to 64 for the three age categories. Notice that these age categories are not of equal width. This is about a 20-year gap. This is about a 20-year gap. This is barely more than a 10-year gap. So they're smaller. This isn't an x-axis where I'm labeling all the years or all the ages. It's just three categories. On the vertical axis, I'm going to do the proportion. I've already got the age group on my horizontal axis. I need to make 3 bars for a bar graph. The first one is going to be the tallest. That needs to go up to 45%. So I'm going to make my graph go up to 50%. And that just 10, 20, 30, 40. So these are percentages or proportions. You could do 0.1, 0.2, 0.3, 0.4, 0.5, or just label them with percentages. I'm going by tens. And that first bar is going to go up to 45, so up to here. I need to make a bar this tall. And it's easiest if you draw the top first and then just bring the sides down to make that rectangle. That's my first bar, representing the proportion for my first age group. The second one goes up to 36, up there. And there's the bar for the second age group. And then finally, 19% is right about here. There's the bar for the third age group. With lined paper, these are vertical bars, so they're fairly easy to see. It's just that their tops might be harder to see. But what you can do to make the whole thing easier to visualize is these 3 blocks. There's 45% of my data, there's 36% of my data, and there's 19% of my data. That corresponds to the size of these blocks. It also corresponds to the area, which we're going to see is much more important when we study the histogram. And the histogram is like a bar graph, except the bars are shoulder to shoulder. We'll see that in the next section.